I am talking about lenses today. Has everyone used functional lenses? Okay, oh wow, way more people than I expected. Well, anyway, I just learned about this recently. I actually learned about it from Amar here in the audience. Thank you, Amar. We use lenses at the company, Lightweight Labs, and actually lenses are really cool, so I just wanted to share like some stuff that's cool about lenses. So, have you ever been stuck reading or writing a data format that is like kind of inconvenient and you don't have control over it? It happens to me all the time with like JSON APIs. So we're going to run through a lightning example of this, okay? Suppose you're using some sort of JSON API that represents the data like this. We're talking about people data, okay? And it looks like this. There's like an API person. They give the ID as a string, but it's actually a number. They give a birthday as a string. And then they have this like nesting of names and addresses and stuff. That's not really how us Clojure programmers would represent this data. Conveniently, we might want to make it look more like this. You know, nice flat map. The ID is a number. The date of birth is an actual tick date. We separate first name and last name. And then maybe we don't care about all the full address information. We just care about the zip code. So, you know, without lenses, what you might think about doing is like writing a function that converts an API person into our person. And then if we want to make updates and write it back to the API, we have to write a separate function that converts our representation of person back to an API person. And then if something changes, we have to change both functions. And it's a lot of work. So lenses offer a really cool way to do this using a set of, or using an abstraction that's kind of like composable. And we're going to sort of like hand wave over a bunch of these things because it's lightning talk. So here I'm creating two lenses. I'm creating a string to long lens and a string to tick date lens. And so now that with this long string lens here, I can focus the string 42 and get the number 42. Maybe that's not so exciting, but using the lens over, I can ink the string 42. Normally you can't ink a string, but when you look at that string through a lens, it looks like a number, and you can ink a number. So if I use this lens to ink the string 42, I get the string 43. Now that's pretty cool, right? Similarly with the tick date, whoops, what happened? Yeah, okay, so we have this, you know, string tick date lens. If I focus the lens, I get a time date object. And if I tick ink the string here, I get a string with the incremented date. Okay, so that's one thing lenses are cool. So now we're going to keep going because ultimately we're just building building blocks so that we can get this API person data to look like the representation that we want. And so we're building this up like one step at a time using lenses. So now here's two more lenses. Okay, we have the first name lens and the last name lens, and this uses like a higher order lens constructor called the nth token lens that takes, you know, an index and a delimiter. So now let's say we have the full name string, John McCarthy. If I focus the first name lens, I get John. And now we're going to look at pudding, okay? So basically, I can take this full name, John McCarthy, I can look at it through my first name lens here, and then I can put a new string. And what do I get? A full name string with the new value as the first name. Similarly, let's test out last name. That works too. I can put a new value into the last name, and I get back, you know, our full name string. And so with these building blocks, we can now create a whole person lens. Looks like this. Make that code a little bigger. So we're creating an associative lens, and we are using composition of lenses. So, you know, nice flat map. Our person ID is comp. This is just Clojure comp here. And then L key gives you a lens that looks at a key of a map. And then we're just using a Clojure comp of that with our, you know, string to long lens. And then date of birth is similar. We're taking the birthday key and composing that with our tick date lens. Then here for first name, we're using the L/in lens constructor. Oh, look at that. It even pops up the documentation. You know, it returns a lens that focuses the given path in an associate data structure. And so we're doing that and composing that with our first name and the last name. And then finally, zip is just a straight up, len lens. So let's see if it works. So this is our API person data structure. And now we're going to define P as the focus through our person lens of this API person. Let's see what that looks like. Indeed, it looks the way we wanted it to look. And now if we make an update to this, our representation, our convenient representation by just using, associating a new first name here, our representation now looks like this. And we can do whatever we want to our representation, but eventually we might want to write it back to the API, and we can then put it back through the lens. And indeed, you get it in the shape you want. No custom code, there's no like string, no special casing each update, and we never have to deal with this API representation. We never have to do like a SOS in the nesting or whatever. We can only deal with our representation that we get to design, and the lens takes care of updating that one. And then the only final thing I wanted to say is, you could imagine if this map had like 1 million keys in it, lenses can be written in a way such that you can update one key and there project that onto the underlying data structure in constant time without having to kind of like take your 1 million key data structure and regenerate 1 million key of the other data structure every time you make an update. And that's really cool. So yeah, basically, we apply this abstraction in our company, which deals with the QuickBooks API, and there's like a mess of different data structures. And we had this like multi-thousand line file that was just growing spaghetti code. And then we like refactored it all into lenses, and now it's like a few hundred lines of like composable short lens functions. We're like very happy customers of lenses, and that's it. That's lenses. Dustin asks, okay, I'm going to repeat the question. Dustin asks, talk more about performance. In our experience, lenses are super high performance. So like, let's look, like if you look at this core library that we're using for lenses is lentis.core, it's like everything ends up being function calls. So just look, this is the implementation of a lens. And it takes a while. You have to spend some quality time with this code to understand it, but it's mostly function calls. So like, all your lens stuff ends up being very fast, in my experience.
I want to update like a leaf of 10,000 objects.
A leaf of 10,000 objects?
Yeah.
Like, what do you mean?
I don't know, you have lenses over 10,000 rows of financial data or whatever, and I want to increment one of the cells in the row.
Yeah, if you can write your lenses in a performance-aware way so that that's just like a constant time update, yes. The question was about like if you have like lots of data that you're lensing, what's the performance of making an update to a single piece of it?
Can I say something? It transports the function to where it's necessary, basically.
Okay, yeah.
I'm not paying for it.
Amar, who taught me about lenses in the first place, comments that I'll just repeat his comment. He says that it transforms your
It transports the function to where it's needed.
Okay, transports the function to where it's needed. That's a very good way of putting it. Thank you, Amar. Yeah.
Don't you have to like reconstruct the data structure in the end? I guess you don't do that until you ask for it.
Implicitly, like the lens it holds the construction of the data structure in its construction.
Okay.
Is the answer. Cool. Another question. Nick, yeah.
Why do you think lenses haven't gone big until now?
Why have lenses not gone big until now? I don't know. Now could be the moment. This conference could be the moment where lenses go big. Yeah, I don't know. Here, 2025 this is the year. Yes.
What happens if you try to look at a zip code through a last name lens?
What happens if you try to look at a zip code through a last name lens? I'm going to guess we're getting an exception because it's going to look for, I think it's going to look for, so you're saying focus last name of a zip code. I think we got an exception here somewhere. REPL. Yeah, execution error, index out of bounds exception. So that's because I didn't handle this case in the last name lens. If we look at the last name lens, it is calling the nth token lens, which is this is the implementation of the nth token lens. and it just calls nth on string split, and so it makes an assumption there. So yes.
Following up on that, your full name example has me wondering about increasing the complexity of lenses. Right? Imagine a name in all its full glorious complexity.
Yeah.
Dr. John C. McCarthy III.
Oh, yeah. Okay, yeah, right. So for this example, there's a strong assumption here, which is that in this API, full name is always like a string with one space in it. That bit might be a bad assumption, and we might have to do like more complicated lens to like decide what's the first, what's the last. Yeah, it's really just kind of like a contrived example to show what lenses can do. But yes, names are much more complicated than like string space string. Yeah.
All right, I was just wondering if there's
Okay.
an example history there of people who've done that kind of complex lens.
Oh, yeah. I mean, I think if I were parsing, if I were actually had the job of parsing a like complex string representing a name, and I had to read and write parts of that name, like first name, middle name, last name, and then have all these heuristic about like figuring out what is the middle name, I would do it using lenses like this. Yeah. Yes.
Can I make a lens of a lens? Will the property changes across?
Can you make a lens of a lens? We can compose lenses together like that. That's kind of like making a lens of a lens. That's usually what you want to do here. Yeah. Cool. Okay, lenses, enjoy.